Hi, I'm Donald Sinclair. I'm a science teacher with Great London Tutors, and today we're going to be looking at a few topics in chemistry. This is how to calculate mass in chemical equations. A mole is a unit that tells you how much of something there is. It's defined as 6 times 10 to the 23 atoms or ions or molecules or whatever's most appropriate. 6 times 10 to the 23, of course, is 6 followed by 23 zeros. So it's a very large number, but because atoms, ions and molecules are very small, it's appropriate to use a very large number. This is called Avogadro's number, after the scientist who first came up with it. This means that if you have 1 mole of water, for example, that means you have 6 times 10 to the 23 water molecules, and so on. Now, the relative formula mass of an atom or a molecule tells you how much 1 mole of that thing will weigh in grams. So for example, if you had 1 mole of magnesium, which means if you had 6 times 10 to the 23 magnesium atoms, that means it would weigh 24 grams. You can work out the formula mass for molecules very easily. So for example, water, 1 molecule contains 2 hydrogen atoms, 1 oxygen atom, which is 1 plus 1 plus 16. So the relative formula mass of water is 18. This means that 1 mole of water will weigh 18 grams, so we'll have a mass of 18 grams. Let's look at an example where the idea of moles allows us to predict what masses are involved in a chemical reaction. For example, here we have the reaction of magnesium with oxygen to form magnesium oxide. Now, it's already been balanced, and the numbers tell you how much or how many moles of that substance will react with how many moles of the other. So for example, we can see that 2 moles of magnesium react with 1 mole of oxygen molecules to form 2 moles of magnesium oxide molecules. Now, if we find the masses involved here, 2 moles of magnesium will have a mass of 48 grams. Since 1 mole of magnesium has a mass of 24 grams. 1 mole of oxygen molecules will have a mass of 16 times 2 equals 32 grams. 1 mole of magnesium oxide would be 24 plus 16 equals 40. However, because there's 2 of them, we have a total mass on the right hand side of 80 grams. Now always the masses on the left hand side should equal the masses on the right hand side. So here 48 plus 32 equals 80, which is what we have on the right hand side. So let's say we were asked to work out if we had 3 grams of magnesium reacting with excess oxygen, in other words, as much oxygen as is needed for the reaction, what mass of magnesium oxide would we have at the end? We work out in this way. We know that 1 mole of magnesium has a mass of 24 grams. So if we only have 3 grams, what fraction of a mole is that? Well, it will be 3 over 24, which is 0.125 or 1/8 of a mole. So we know that we have 1/8 or 0.125 moles of magnesium reacting. We can see from the equation that 2 moles of magnesium would give us 2 moles of magnesium oxide. In other words, it's a 2-to-2 ratio. Or more simply, a 1-to-1 ratio. That means if we have 0.125 moles of magnesium reacting, that means we're going to have 0.125 moles of magnesium at the end. So we also have 0.125 moles of magnesium oxide. How much does, or what is the mass of 1 mole of magnesium oxide? We worked that out earlier. It's 24 plus 16 is 40 grams. So 1 mole has a mass of 40 grams. However, we've just seen that we only have 0.125 moles. So 0.125, which is the number of moles, times the mass of 1 mole, which is 40, is 0.125 times 40, which is 5. So we have 5 grams of magnesium oxide from 3 grams of magnesium reacting with oxygen.